Alright, and so finally one more video with exponent rules, the level 2. Level 2, we're just going to combine the 5 rules we've already talked about, making you use 2 or 3 of them per problem instead of just one at a time. So, some advice. If you have just part of your problem in parentheses, we're going to have to get rid of the parentheses first. So there's nothing inside of the parentheses that we can simplify, so we're just going to have to use our exponent rule and multiply our 4 times our exponent of 2. And then remember that the 3 has an exponent of 1. We're going to have to multiply that as well. So step 1 would be to get 3 to the 4th, x to the 8th here, while nothing changes to the 6x cubed. Now we would want to pull out our calculator and figure out that 3 to the 4th is 81. So we can see if 81 divided by 6, the two coefficients, can do any simplifying. I believe they can both divide by 3. So that would be 27 over 2. And here's our second exponent rule. When the bases are the same and we have division, we need to subtract powers. So 8 minus 3 would be 5. The answer to those quotient rule problems goes on the top. And if it's positive, like this one is, it stays there. Okay? So that's as simplified as that would be. Not too bad. We use 2 of our exponent rules in that situation. The one beside it looks more difficult, so let's get started. This one, since the exponents have a lot more things in it, I like to do some simplifying first. I like to realize, oh, I have 2 x's here, so I can go ahead and subtract their exponents. When I subtract 2 and 4, I'll get x to the negative 2, right? And then I can do the same thing for the y's. Remember, if you don't see the exponent, it's an invisible 1. So here I would have negative 2 minus 1, which would be negative 3. So y to the negative 3. So if I see common bases inside my parentheses, I like to combine them first. So now when I am using my power rule and multiplying my powers, I have a little less to do. Don't forget that this 3 has an invisible 1 on it, like all coefficients do. So that should become 3 squared, x to the negative 4, y to the negative 6. 3 squared, I can turn into 9. The negative exponent on the x tells me the x are not happy where they are. They would like to move down. And same story with the y's. Negative exponent tells me they're not happy beside the 9 either. They'd like to move down. So we're going to end up with x to the 4th and y to the 6th in our denominator, and only our 9 left in our numerator because it's the only thing that had a positive exponent on it. Okay. I have 2 more hiding at the bottom. Okay, this one is the same. We'd like to simplify what I can first. So I see 2 things to focus on. One is that my x's have the same base here, so I can subtract 2 and 5 and get negative 3. So I will have w x to the negative 3. Remember, the answer to those subtractions go in the numerator. And the other thing I notice is that I have a w to the 0. And you remember, anything to the 0 crosses out and becomes a 1. So I have 1 y to the negative 3 here. Of course, I don't have to write that 1. 1y is the same as y, so I will stop writing it in the next step. Okay, so now I've simplified what I can. I have to put my invisible 1 exponent on my 4. Sure, my invisible 1 exponent can go on my 1 as well, but I don't need it. And now I'm going to multiply my exponents. So 4 to the negative 2, x to the positive 6, 1 to the negative 2, if I still have my 1, y to the positive 6. I'll notice that my x's are happy, my y's are happy, but my number is not. So my 4 squared will move down, my 1 squared will move up. Again, that's just a 1. I don't even have to have written it. So I have 1 squared with my x to the 6th, and I'll have 4 squared with my y to the 6th. 1 squared is just 1, so I have x to the 6th. 4 squared is 16, y to the 6th. I never, ever, ever had to write this 1, so I never had to put the exponent on it. But if you do, it still works through just fine, getting us to this answer there. This used 3 of the exponent rules: the quotient rule, the zero rule, the power rule, actually I'm sorry, 4, and the negative exponent rule. So I used 4 of the 5 rules. So there's a lot going on in that. Okay, final one. Remember that if something is not a fraction, you put a 1 under it. So that should help us know that the 3x y to the 7th should be multiplied with the 2x to the negative 2. And then the 1 just gets multiplied by y to the 3rd. So step 1, I would say, in this one would be to combine by multiplying the numerators of the 2 fractions. So 3 times 2, multiply the big number, gets 6. So I wrote the wrong number. 3 times 2, multiply and get 6. X times x to the negative 2. Remember, when you multiply, you want to add the exponents. And remember, there's an invisible exponent on that one right there. So that's going to be 1 plus negative 2, so that's going to be x to the negative 1. And then there's a y to the 7. And then down in the denominators, 1 times y to the 3rd is a y to the 3rd. Okay, so now that it's part of one fraction, I realize I have y's divided by y's, so I can subtract my exponents. 7 minus 3 will be 4. And now I can analyze what I have. 6 has a positive exponent. X's have negative exponents, so they want to move. Y has positive exponents, so it's happy to stay. So 6 and y to the 4th will squish together closer. X to the 1st will move to the bottom, or perhaps you just want to write x because you don't have to write that invisible 1 exponent. Either one of those is fine. Shows that you know what you're doing. Okay, so give your level 2s a try and follow up with questions as needed.